In this demonstration, you'll learn how BladeModeler can be used to extract the blade geometry from a CAD model for later use. I'll be showing you how to extract the required sketches, how to create a flow path feature and a CAD import feature, and how to write and run the script file to recreate the blade geometry. Presented here is the CAD model for a centrifugal compressor. I want to extract the design intent of the blades so that I can easily change the blade shape. In other words, I want to extract the camber line and thickness distribution for the impeller blades. This can be done using the CAD import feature. First, I'll rotate my model so that the global Z direction points upwards using a body transformation as shown. It's also necessary to ensure the model rotates about the Z axis before further steps are performed. My model already rotates about the Z axis, so no transformation is required. After I've met these requirements, I'll need to create sketches of the hub, shroud, inlet, and outlet for the flow path feature. There are different ways to do this. I'll do it by creating a cross-section of the fluid path on the ZX plane and extracting the sketches from my cross-section. I'll start by rotating the fluid path around the Z-axis using the Revolve tool. Next, I'll slice the resulting body along the ZX plane using the Slice tool, and hide one of the halves so I can see the cross-section I've made. These sketches need to be on the positive X, positive Z region of the ZX plane, so I'll use this side of the body I created. To create sketch projections, I'll need a new plane based on the ZX plane. Right-clicking the plane, I can select Insert, Sketch Projection, and select the corresponding edges to create a sketch projection. Each sketch must be generated individually. Here I am creating the sketch for the hub. Here is the model after all sketch projections have been made. Now I have the required sketches to create a flow path. I can select the machine type for later post-processing, and set the contours for the hub, shroud, inlet, and outlet. Once the flow path has been specified, I will click Generate. Now I have what I need to create a CAD import feature. I'll select the flow path I just created, and I'll also need to specify blade surfaces as shown. In the CAD import feature, I can specify a number of details about the blade geometry, including number of blade sets, the details of the leading and trailing edges, and camber line simplification details. After specifying the CAD import feature, I will click Generate. In the auxiliary view, I can compare the generated geometry, indicated by the blue dots, with the original geometry, indicated by the gray dots. I find the result acceptable, so I can now export the script file for importing the geometry elsewhere. In a new Design Modeler window, I'll import the geometry by running the previously made script file. I can now make small edits to the blade geometry by clicking on the newly created CAD Import Blade feature in the tree outline, adjusting points for the angles and thickness, and clicking Generate. Here I'm showing two examples. This concludes the demonstration on using the CAD import feature to extract the blade geometry from a CAD model.